Hello there. I'm Patrick McCabe, a product manager with Ixia, a Keysight business. And today we're going to be sharing a demo of the network packet broker environment. So what we've actually done is created a sample environment that mimics a small data center. Um, Obviously, this is just an example, but for the purposes of setting up a demonstration and configuration, we figured this would make a good example of how our solutions are used in production networks. So what we have on the left-hand side of this diagram that you're seeing is what would be a small production network. A couple of firewalls, a couple of core routers, some data center switches, some physical servers, and some virtual machines running in VMware. Also on this network, we've deployed some Ixia access products, which help us get visibility into the network. So you'll see between our core routers and switches, we actually have some physical taps that are monitoring that traffic. Between our core routers and our firewalls, we have some bypass switches, which allow us to get production data off of the wire and also allows us to feed inline tools. So you figure an intrusion prevention system or IPS. That device is a kind of a device that actually wants to actively block traffic if it detects something violating a security signature. So for those types of tools, we need a device that is physically in line, and that's why we have some bypass switches. For the VMware environment, we also have virtual taps. So at Ixia, we call that Cloud Lens. And so our Cloud Lens virtual taps are actually monitoring the VMware environment and feeding that traffic to our network packet broker. Now, at the center of this is what we're demoing today is VisionOne, which is one of our Vision series network packet brokers that has support for pretty much every feature that Ixia has to offer. And in this demonstration, we're going to talk about a few of those. So SSL decryption, deduplication, header stripping, load balancing, and there's much more. But for this demo, we're going to limit it to just a few features and show you why you would use those features and tie them to some real-world examples. And then on the right-hand side of this diagram, we also have the tools that we'll be using in this environment. So we talked about the IPS, which will be an inline security tool. We have a forensics tool, which wants to grab traffic from multiple sources on the network, but requires deduplication. If you think about a forensics tool that's capturing every single packet and storing that somewhere, storing duplicate packets means you need more hard drive space, or you're going to reduce the retention time for your forensics tools. So deduplication here helps make the life of the tool last longer. And we're also going to do some load balancing, because if we capture network traffic from all of these sources, it's going to be a lot of traffic. So this forensics tool probably has more than one port. And so we'll show you how to create some load balancing techniques inside our packet brokers. We'll also walk through a performance monitor. So this is an example of an application performance monitoring tool that wants to monitor web traffic, but requires header stripping because this particular tool doesn't understand Cisco ACI. And our data center switches are talking ACI, so there's VXLAN headers on the network. And so our Vision network packet broker is going to strip off those unnecessary VXLAN headers that our performance monitoring tool doesn't know how to read or understand. And then finally, we have a packet analyzer. You can think of this as just a Wireshark running on a laptop. This is great for those troubleshooting exercises where you're trying to pinpoint a specific flow or a specific piece of traffic in the network and do a packet capture and do some packet analysis on that. So we'll show you how we can set up custom filters on the fly for different types of traffic. Without further ado, let's get into the demo. So at this point, we're going to move into the web interface for our VisionOne network packet broker. So we'll go ahead and log in and give you a quick tour of the environment. So what you're presented with right at the beginning is our diagram view. The diagram view actually shows us how the system is configured based on the connectivity of the ports on the front of a network packet broker. So you'll see some of the ports on the left-hand side, ports 1 through 4 are some network taps. port 5 is connected to our VMware virtual taps. And then port 8 over here is a performance monitor, and we've got some tools on the right-hand side. So let's talk a little bit about that flow from left to right. So on the left is our network ports, and network ports are anything that is a network source of traffic. So you can think of this as a span port, a physical tap, a bypass switch. It could be a virtual tap, or anything that could be forwarding us traffic to this packet broker in a wire data format. Right. So this is the source of traffic, so your source ports, if you will. On the right-hand side, we have our tools. So these are the devices that actually consume wire data. So you have your performance monitor, your forensics tools, your packet analyzers, whatever else may be consuming the wire data that they get from the network packet broker. Then in the middle, we have our dynamic filters. So dynamic filters are something that's unique to Ixia. We help you map the network ports to the tool ports with dynamic filters. And this filter can choose what traffic gets sent. We can actually perform some advanced functions like header stripping and deduplication, things like that. And then because of this, like 3 stages of the system, the ingress, the backplane, and the egress of our system, we actually allow for very flexible configuration of how packets get routed through a network packet broker. So each of these columns, you can actually set filters. You can say, what traffic to allow through, whether you want to pass by certain criteria or just allow everything through. So in this environment, what we have for the demonstration is we've got some network taps that have already been set up. We've got our virtual taps set up as our source ports. And for our virtual tap, you'll see we've actually got it configured to have an IP address, which means we can configure all of our virtual taps to send their traffic to this 172.16.100.10 address in a L2 GRE tunnel. We can also do the same thing to receive ER-span traffic. So if you've got an SDN type environment and you want to dynamically send packets from the network to a packet broker, you can set up a port on our system to be an ER-span destination as well. So then what we have on the right-hand side is our tools. You can see we've got our performance monitor is already connected. And from our demo, we said this performance monitor tool did not understand VXLAN traffic. And so we'll come into packet processing and do VXLAN stripping, configure it for the Cisco VXLAN flavor, and then hit OK. And what that means is now if this port sees any traffic that has a VXLAN header on it, it will go ahead and strip that header off so that you can see what was actually encapsulated in there. For some tools, they simply don't understand VXLAN. And for other tools, it's more efficient for the tool to not see those headers and have to do some more deep packet inspection. And then in the center here, we have a very basic filter that's set for all traffic. And when I go to the filter criteria, I can see that it's pass all. Now for this filter, I could come in here and set things like match on certain MAC addresses, VLANs, IP protocols, layer 4 port numbers. I can even look at some TCP control messages and filter based on that. So there's a lot of flexibility in how we configure these filters. But for this particular use case, the performance monitor wanted to see all traffic, just take off those VXLAN headers. The next tool that we had was our forensics tool. And you'll notice I've got forensics 1, forensics 2, because this tool actually has 2 ports. So it has the capacity to record traffic at 20 gigabits per second. And so what I can do is come in here and select both of these forensics tools and go to port grouping and create a load balance port group. It's going to say, do we want to create a port with the port group with these 2 ports? I say yes. It's going to reset my statistics. And then you'll see on the right-hand side, it created a load balance port group that it shows a speed of 20 gigs. So I'm going to go ahead and hit yes, and we'll come in and configure this port to be our forensics tool. Okay. And now we have a forensics tool. So now we would have to connect this tool to some kind of source. So we could just simply drag and drop to the first of our network taps, and it says a dynamic filter called filter 2 has been created. So now this particular forensics tool, we really only care about web traffic. So I'm going to create a filter that just matches on web traffic. And then to do that, I'll go to pass by criteria, match on layer 4 port, and then whether it's source or destination, depending on the directionality of the traffic. I care about, ports 80 and port 443. Keep typing the wrong numbers, but there we go. And so now I'm matching on ports 80 and 443. You could add any other ports here. And then we could also do a layer 7 filter if we used our AppStack engine to match on web traffic that was running on non-standard ports, but that's outside the scope of this demo. So I'm going to go ahead and hit OK. And so now you'll see we've actually drawn a line. So this network tap 1 is actually regenerating traffic. So it's going to send traffic to our forensics tool and to our performance monitoring tool. And it's actually using 2 different filters. What's nice about this way of setting up our filter rules is it doesn't involve complex access lists. It's all what you see is what you get. It's drag and drop configuration, and you don't have to think about, what are some of these conflicting rules? Like, is there some web traffic that's going to get sent to performance monitoring? Yes, because it actually has like an all traffic filter. But things that aren't web traffic don't need to get sent to our forensics tool, so we don't actually need to worry about setting up those rules, because what you see is what you get. So now, if we wanted to connect this filter to our other taps, we could do that as well. So we have drag and drop, but we also have some faster workflows, so you can actually grab multiple ports at the same time. So I'm just shift clicking and selecting multiple ports, and then I hit OK. It's going to reset my statistics every time I make a change like that. And so now you'll see each of these tap ports, whether it's the virtual taps or the physical taps, is actually regenerating traffic to both of these tools. And then for the forensics tool, because we have multiple tool ports, it's actually load balancing across those 2 different tool ports. So now additionally, we said that we wanted to perform deduplication on this particular forensics tool. So what I'll do here is actually attach one of our resources for a packet stack or advanced features, and say we're going to assume it's about 20 gigs of traffic. So we'll allocate 20 gigs of processing. And then now I can come into this filter and configure the packet processing to turn on deduplication. So I can actually use a time check to determine, when did the packets arrive, because if they arrive too far apart from each other, they're probably not duplicates. And then I can also select which headers I want to care about in determining duplicates. So if we think about duplicates, you can have packets arriving from multiple taps in the network in different places. So where they capture the packet, the MAC addresses might be different, IP addresses might be different, time to live and the IP header might have changed. So depending on what headers you care about for matching, what is a duplicate, what do you consider the payload versus the headers, this is where we can actually come in and make some choices and say, well, maybe I only care about layer 2 information being different to cause a duplicate. So I'll select MAC, VLAN, and MPLS tags. And then I'll go ahead and hit OK. And now what will happen is all these packets that flow through here will get deduplicated before they get sent to the forensics tool. Now I can attach additional tools to this same filter, and now both of those tools will actually get like a deduplicated feed of just web traffic. So this filter can also regenerate packets just like our network tap did. And this is something that's unique to the way Ixia sets up our dynamic filters. Now, for this packet analyzer, we actually had something special in mind, so I'm going to disconnect it from my web traffic filter, but I wanted to demonstrate that that was something that's totally doable from Ixia's configuration. So we talked about this packet analyzer as being something that's great for troubleshooting. So let's walk through one of those troubleshooting efforts. If I wanted to just say quickly monitor my virtual environment, because I got a call from a user and they're having an issue, I could call this my troubleshooting filter, and then come in here and set very specific criteria. So I may have a specific user that I know their IP address, so I could say the user at 172.16.50.45. With a mask of 32, so just this particular IP address. And then they may be having trouble with a specific application. So I could come in here and pick from one of our many applications, but we could pick something like FTP data because they're having trouble transmitting data over FTP. Okay, and then they may only care about the traffic that's running on VLAN 100 because of the user being located on VLAN 100. The reason I'm showing this is that we can use multiple different filter vectors. So whether it's VLAN, IP address, port number, doesn't really matter as long as all these things match. And so this helps me narrow down my data very quickly. What's also nice about this is that I can go ahead and create this filter real quick, and it does not impact any of the data that was flowing to web traffic, and it does not impact any of the data that was flowing to the all traffic filter. This was done dynamically without any impact to any of the other tools or the data that they saw. Why that's important is some other visibility solutions actually require you to build very complex access lists to map traffic from port to port. And usually a very specific rule like this, where we're matching on a VLAN, an IP address, and a layer 4 destination port, has to be the first rule in your list. So to make changes, you'd have to change the whole map for everything that's going through the system. And at Ixia, we just didn't feel like that type of disruptive behavior was a good design. And so we've designed our solution to be very easy to implement without causing any performance impact to any of the other tools that might be monitoring. So once this troubleshooting effort is over, I can just come in and delete this connection to my virtual taps, and life is good. Now this troubleshooting filter is going to sit idly until the next time that we're ready for traffic. So this kind of shows just a little bit of how we map in a drag and drop way from left to right. We can allocate features for like deduplication or header stripping. They can live either directly on a tool port, they can live on a dynamic filter to operate on the backplane and then regenerate those packets to multiple tools. So there's many different ways to use the different features of the Ixia Packet Broker. So next, we're going to talk a little bit about our inline tools, because up until now, we've been talking about analyzer tools and forensics tools that have all been out of band. So let's move to the inline diagram. So now that we've moved over to the inline screen, you'll see we have a blank slate. This is the screen where we actually get to define how we're going to service chain traffic through the network packet broker from the production network to these active inline tools. So very first step is to actually tell this packet broker where our bypass ports are. So this would be the connection of the bypass switch that goes to the firewall. This would be the connection that goes to that core router. And we'll call this our bypass switch. Okay. And you'll see now we've got ports here that look similar to network ports and tool ports in the diagram view, except they're in line. So traffic actually is flowing in both directions, left and right. And so what we have to do to connect these tools together is create a service chain, because we don't have a service chain yet to connect these two. So I'll go ahead and hit add service chain for decryption. And I'll go ahead and drag and drop here. And you'll see now we've got a connection to a service chain which has no tools or anything in it. But now we can pass traffic from left to right, and as the arrowheads kind of point to us, traffic can flow from right to left as well. So the next thing that we would want to do is enable our active SSL. So I'm going to go ahead and create a new instance for SSL decrypt. And I'm going to make this an active deployment. So we could do a passive deployment and decrypt traffic and feed to an out-of-band tool. But in this demo, we're feeding an IPS, which is an inline tool that has two interfaces, a northbound and a southbound. And so I'll go with that. And so now you'll see two things happened. I've got a new set of bypass port pairs for traffic sources. And this is actually the decrypted traffic coming out of our SSL decryption. And then we have a tool resource for SSL decryption as well. So I can go into my service chain now and add the inline tool resource for active SSL decrypt. And it's currently set to be fail closed. I'm going to show you that I can flip that to be failed open. So if anything were to happen with our SSL decryption or the intrusion prevention device on the other end, this service chain would continue to pass traffic because we've configured it to be fail open. Now the next step is we're sending traffic from this bypass switch. It's hitting the active SSL, getting decrypted, and it's going to come out these two ports here. So now we have to configure our IPS. So I'm going to go ahead and build my IPS. And then I can say this is a Cisco Firepower. So use a Cisco Firepower heartbeat. And what's nice about this is this will keep track of the health of that Cisco device. Rather than just looking at is the interface up or down, it's going to send packets through that firewall or that IPS to make sure that it is actually processing packets. So not is it up or down, but did it get sick or is it unhealthy? So a heartbeat actually helps us measure whether or not the traffic is flowing properly. Now that I've got an IPS device, I can create a new service chain for my IPS. And then I can go to the inline tool resource and add my IPS tool and hit OK. And now I can direct my traffic that is decrypted into my IPS. So in that short amount of time, what I've actually set up is the ability to take traffic from the production network, send it through a decryption engine, send the decrypted traffic into an IPS, and when I return that traffic back, send it out to the other side of the bypass network. So actually what's happening here is now the Ixia VisionOne is decrypting those packets, and we cover the setup of this this active SSL engine in another video, but this is going to decrypt these packets, send the decrypted packets to my IPS so that it actually is only looking at clear text packets. So that about concludes our demonstration of the VisionOne Network Packet Broker. So hopefully with this demo you've seen how easy it is to set up a visibility fabric in a small data center. It's easy to set up with a drag and drop interface. The interface is what you see is what you get. So when you have traffic routed from one place to another with different filters, you can be sure that the packets are going to arrive where you sent them to go without having to build complex access lists. We've also shown how easy it is to set up SSL decryption for inline tools. We can service chain multiple devices and make it super simple. And so I think what you've seen should be enough to tell you that you can build a visibility fabric in your environment, and you can do it with Ixia. Thank you.